Hello guys, my name is Nandavardhan Reddy from Informational Technology, bearing roll number 20951248. Today's subject is Fundamentals of Multimedia. Subject code AITC 13. Today topic is compression types. We'll go through the topics. First, introduction. The major reason for applying the compression techniques on data, we can reduce storage requirement, process time, and transmission during compression. Compression allows a more efficient means to save memory capacity and transformation of bandwidth and also the transmission duration. During the past years has compressed compared the contribution of compression. The fact that nowadays compression technology plays an important role in our life because it changes the way of working on multimedia as image, video, text, audio, speech, etc. The basic purpose of compression is that we can beam data with a minimal number of numbers according to human visual description. A digital image has data content or redundant and irrelevant information. For reducing redundancy, we just focus on replication from the source of the image. On the other hand, data signals which is omitted from source remove the signals is not received by the receiver, such as human visual prescription is called irrelevancy reduction. Elimination the redundant information from the image, saving up storage space of the image. The compression techniques designed for future challenges and advanced application for multimedia and communication system. There are several compression techniques, but the main two categories are lossless and lossy compression techniques. Lossy compression, there is no loss of information from image. Lossless gives 100% recovery data from the original data. On the other hand, the lossy compression technique gives a high compression ratio. Compression algorithm. Digital image compression is the major research areas due to continuously increasing various applicants in different fields. This section reviews the data digital compression algorithm. Here are compressional techniques: lossy compression, lossless compression. Here in lossy compression, we have vector quantization, transform coding, wavelet compression. In lossless compression, Hoffman coding, real early coding, incremental encoding. These are the things. Lossless compression technique. The need of lossless compression technique is required in many applications, such in space, such in medical data. There were no loss of information. Lossless compression reduces storage space without degrading image and time needed for computational work. Also decrease. The lossless image compression algorithm for different applications like medical image, lossless interframe coding for MRI image, ultrasound image, capsule encoding image. The different techniques that are used in lossless compression are Hoffman coding, Shannon Fano coding, run length coding, arithmetic coding, Golo MB coding, and symbol based coding. Dictionary algorithms such as LWZ, area coding, bit plane coding, byte pair coding, lossless predictive coding, predictive partial matching act. In lossy compression technique, lossy compression technique gives the high compression ratio than lossless, but the loss of data are as compared to lossless compression. Lossy compression consists of three parts. The first is a transformation, which gives a high comparison ratio. The second part is quantization, which is reduce a symbol of bit represent the image, gives a key issue which distinguishes between lossy or lossless compression methods. At the end, used comparison for entropy encoding. The most basic comparison techniques are described here. Null comparison replaces series of blank spaces with a comparison code, followed by a value that represents the number of spaces. Run length comparisons expands on the null comparison technique by compression any series of four or more repeating characters. The characters are replaced with a compression code, one of the characters and a value that represent the number of characters to repeat. Some synchronous data transmission can be compressed by as much as 98% using this scheme. Keyword encoding creates a table with values that represent common sets of characters frequently occurring word words like for and the or character pairs like sh or th are represented with the tokens used to store or transmit the characters. Adaptive Hoffman coding and Leflage algorithm. This comparison technique uses a symbol dictionary to represent recurring patterns. The dictionary is dynamically updated during a comparison as well as new patterns occurs. For data transmission, the dictionary is passed to receiving system, so it knows how to decode the characters. For file storage, the dictionary is stored with the compressed files. Discrete cosine transformation. Discrete cosine transformation most suitable for medical image compression. A discrete cosine transformation is a sequence of finite data points in terms of sum, the sum by cosine function at different frequencies. The two-dimensional DCT is the essence of most popular lossy digital compression system today. Okay, 3D discrete cosine. 3D discrete cosine is used in image and video compression method for both JPEG and MPEG. But these methods are not lossless. The three-dimensional discrete cosine transformation is used to produce a spectral frequency spectrum. Image compression using neural network. A neural network images compression follows the following steps. Store the color image for moderate size. For decomposing the discrete wavelet transform is used to the image for obtaining approximate coefficient. For bitstream, Hoffman coding is used to compress image. By reverse process, we obtain reconstruction. Discrete wavelet transform. Discrete wavelet transform is applied on denoise image. Frequent regulate transform f of dt is used to obtain wavelet coefficient. Compressed image of reducer size is obtained. Decompression is completely by applying an inverse finite regulate transform f and discrete wavelet transform under the original image is obtained without loss of data. These new techniques for image compression gives benefits for medical applications, reduce computational complexity, mean square error, high compression ratio, and better efficiency are obtained. The steps are converted into image, input image 256 to 256, converted RGB to gray. The third step is future extraction is done. Input image data is segmented and transformed to a set of features. For last stage, decomposed image binary decoding is implemented. We came to the conclusion regarding video and audio to a digital format involves balancing quality with a file size and bitrate. Most formats use compression to reduce file size and bitrate by selectively reducing quality. Without the effect of quality video to reduce the file size and bitrate of the image in micro-based. To reduce 4.7 GB DVD video to less than 700 MB CD, compression is essential for reducing the file size. Here the file size is reduced from 4.6 GB data to 700 MB data. Means the video is compressed almost 7 times less than original data. Okay, so that they can be stored, transmitted, and playback efficiently with the less storage space for more data. Okay, to reduce the storage space is useful for not only the multimedia system, it is more required and essential for marketing, military, and for the sports data. Thank you.